Ions may be positively charged or negatively charged. The ones that are positively charged are known as cations, and the ones that are negatively charged are known as anions.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
Hello everyone, Teacher Alan once again. In the previous video, we introduced the topic and we gave key terms, and I'm certain whoever watched it is informed about it, is informed about the terms and what they mean. So I'm going to apply all these terms in the next videos and in the next parts of electrolysis. For today, we are going to look at the concept of decomposition of electrolytes. When we talk of the word decomposition, we said that it can also mean ionization, it can also mean breakdown. We are looking at how different electrolytes decompose or break down when an electric current passes through them. And we said that the electrolytes can only decompose when an electric current passes through them. And the only electrolytes that can decompose when an electric current passes through them are the ones that are in aqueous, or molten states. So let us assume the electrolyte is sodium iodide. Sodium iodide is of that, let's say the electrolyte is molten. Let us assume the electrolyte is molten sodium iodide. Members, sodium iodide is of this formula. It is molten, meaning that its solid state was changed to a liquid state by increasing temperature, so that its atoms, its ions, or the ions in it are set free to a liquid. This one, when an electric current passes through it, for lead, it will completely ionize. We are saying in molten state, that is when it is a liquid. It will ionize to give free sodium ions that will be in aqueous state and iodide ions. So for molten compounds, the substance is purely that substance, but in liquid state. Let us assume the solution, the electrolyte is, let's say, aqueous potassium iodide. Let us assume it is the electrolyte. When in aqueous state, it means this electrolyte was previously dissolved in water to form a solution. So this means that in this electrolyte, there is both water and that very electrolyte, which is potassium iodide, because it is an aqueous form, meaning that it is dissolved in water. So when an electric current passes through it, we shall have the water that is dissolved in the electrolyte or this ionic substance. The water will also undergo ionization. This is a weak electrolyte. It will undergo partial ionization to give hydrogen ions and hydroxide ions. I think the equation is balancing. And then the potassium iodide, which is an ionic compound in aqueous state, it is a strong electrolyte, will ionize to give potassium ions and iodide ions. We are looking at the concept of ionization. So this means we have two categories of ions in this electrolyte. We have the positively charged ions, which are hydrogen and potassium, and then the negatively charged, we have the hydroxide ions and the iodide ions. So the ions, what I didn't tell you about, the ions may be positively charged or negatively charged. The ones that are positively charged are known as cations, and the ones that are negatively charged are known as anions. So we have two cations, that is the hydrogen from the water, which dissolved formally the ionic compound, and the potassium ions from the ionic compound. And the anions we have the hydroxide ions from water and the iodide ions from the ionic compound. We've said that the cations are positively charged ions. The anions are negatively charged ions. Let us assume the electrolyte. Assume that the electrolyte is let's say copper 2 chloride solution. Let us assume it is the electrolyte. I want us to understand this concept well. Being a solution, it means the copper 2 chloride was dissolved in water. And this means that we have two compounds in it. We have the water and the copper 2 chloride. So the two will go and they will undergo, the water will undergo partial ionization to give hydrogen ions and hydroxide ions. And then the copper 2 chloride, being a strong electrolyte, will undergo complete ionization to give copper 2 ions and the chloride ions. So this means in copper 2 chloride solution, we have the cations there. We have the hydrogen ions from water and the copper 2 ions from the copper 2 chloride salt. And then the anions, we have the hydroxyl ions from the water and the chloride ions from the copper to chloride salt. Let us assume again the salt and the electrolyte. Let us assume the electrolyte is dilute sulfuric acid. Being diluted means that the acid was added to water. A certain amount of the acid was added to water. It means that in this electrolyte, there is both water and the compound which is sulfuric what? Acid. So we are looking at the concept of ionization or decomposition. The molten form of any electrolyte is that very electrolyte but in liquid state. Heated into liquid form of it. No additives. No water in it. So this one, the water will undergo still partial ionization to give hydrogen ions and the hydroxyl ions, and then the sulfuric acid, being a strong electrolyte, will undergo complete ionization to give hydrogen ions and the sulfate ions. So, in short, we shall have the cations in this electrolyte. We have the hydrogen ions from the water and the hydrogen ions from the sulfuric acid, and then the anions are the hydroxyl ions from the water and the sulfate from the sulfuric acid. We are looking at the concept of decomposition of different electrolytes. Let us assume the electrolyte is molten leading to bromide. So this is purely leading to bromide in liquid state, no water in it. It means that the electrolyte, which is leading to bromide, will undergo, being a strong electrolyte, will undergo complete ionization to give lead to ions and the bromide ions. So this means the cations in molten lead to bromide, we have only lead to ions, and the anions are only the bromide ions. So you need to know the concept of this decomposition, as it is going to be key in the next part of this charge. That when I'm given a molten form of an electrolyte, it is purely that electrolyte, but in liquid state. And if I'm given a solution of an electrolyte or an aqueous form of an electrolyte, we are talking of a salt mixed with water. So in that electrolyte, there will be two compounds that will be ionizing. That is water and that very ionic compound. Remember, the organic compounds, apart from the acetic acid and some organic acids, the rest of them don't ionize. The alcohols don't ionize. So they are non-electrolytes. Remember, all these ones, yes, they may be strong or weak electrolytes, They will only conduct electricity when in molten or solution state or aqueous state. None of them will conduct electricity in solid state. So this concept of decomposition or ionization or breakdown is crucial. And they only do this, all these electrolytes do this only when an electric current passes through them. And only when an electric current passes through the molten or aqueous form of them. We talked of why the solid form of them do not conduct electricity, because the ions are what? Are locked within their lattices, making the ions not free to move around so as to conduct electricity. But in solution or molten form, the ions are set free. They can move around within the electrolyte to conduct the charge or to carry the charge to and from the electrodes. Members, remember I'm online. Don't forget to subscribe. And if you're watching this video minus watching the previous one, I know you're hearing miracles, you're hearing parables in the Bible. It's better you watch the other video first, the first one, so that you can understand this better. Don't forget to subscribe, like, share, and to inform your other friends that Moto Online is an active platform. I'm Teacher Alan. Let's meet in the next part. And in this next lesson, I'm coming back strictly for the process of discharge, the concept of discharge of ions. How are the ions discharged? What is discharge? As we come back, also sit down and ask yourself, what is discharge? How does it occur? Why? Where? And I think that is in the next lesson. Teacher Alan.